All right, so we're going to look at absolute value equations now today. And so remember, absolute value really just means the distance from 0. So if I'm saying what's the absolute value of 5, I'm really saying where are the places that I can be 5 units away from 0, okay? So I can be 5 units away from 0 over here, and I can be 5 units away on the left side as well. So when we're taking the absolute value, notice we're getting two answers. We're getting x is equal to 5. We're getting x equals negative 5. So that's kind of what we're thinking about as we solve these types of equations, is that we are going to get two answers, and it's going to be the positive number that we see, but also the negative number we see. Kind of see how we split it into two equations there. So our first example here, and then our steps as well. So our equation is absolute value of 2x minus 1 equals 5. And then we have our steps over on this side. So when we're solving these absolute value type equations, first thing we're going to do is we're going to isolate that square root, the absolute value. Okay? The way we isolate the absolute value is with PEMDAS backwards. Okay? So for our particular problem that we have here, we're already isolated. Okay? Notice there's nothing outside of the absolute value for this problem. There's some stuff inside, but there's nothing outside of it. Once we have that isolated, just like the previous side, we're going to get two answers. So we make the right side positive, and then we make the right side negative, because again, it's saying the distance from 0. So I'm going to go ahead and say, all right, 2x minus 1 equals 5, and then 2x minus 1 equals negative 5. We got the absolute value going now, so now we're just going to solve two separate problems for x. So that's step 4. We can check our answer if we like. Um, so we're adding 1 and then dividing by 2. So we get x equals 3. And then when we divide by 2 here, we get x equals negative 2. So our solution set for this one would be negative 2 and positive 3. And if we'd want to double check, we can. If I plug negative 2 in, negative 2 times, 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5, and we take the absolute value negative 5, we do get 5. So that makes sense. If I plug 3 in, 2 times 3 is 6. 6 minus 1 is 5. Absolute value of 5 is also 5. So those two answers do check out if we want to. All right, next problem is a little bit trickier because we don't have the absolute value isolated already. Okay, so therefore we have some work to do before we can make it into the two equations right away. So like we said, we're going to isolate that absolute value using PEMDAS backwards. So I'm undoing addition and subtraction first. So there is a minus 20 in my problem, so I'm going to undo that by adding 20. Remember, we said we are undoing it not, we're undoing it to isolate it. We cannot distribute through an absolute value. Okay. If it's parentheses, we can distribute, but if it's absolute value, we can't. So this is really 4 times the absolute value. So we are going to divide by 4. And so the absolute value is still there. So we have the absolute value of 1 minus 2x equals 5. Now that that absolute value is isolated, now we can go ahead and split into our two equations. 1 minus 2x equals 5, and 1 minus 2x equals negative 5. So here we would subtract 1. And then when we divide by 2, negative 2, we get x equals negative 2 as one answer. We subtract 1. Negative 2x equals negative 6. And when we divide by negative 2, we get x equals 3. So negative 2, positive 3. All right, let's take a look at 74 here. So again, the first thing we need to do here is isolate that absolute value. So I'm subtracting 6. And that's going to give me the absolute value of x plus 1 equals negative 4. What did we say our answer for an absolute value always has to be? So when I'm taking the absolute value of 4, I get 4. Absolute value negative 4 is also 4, right? But in this case, if I take the absolute value of something, can I ever get it equal to negative 4? No. So if you're isolated, if that absolute value is isolated and you get a negative number, it's not possible. So this one would be no solution, or the null set. So you can make your null set. And if you want a little brief explanation, the output for absolute value cannot be negative. So again, if you have steps along the way where there's a negative on the right side, that's fine. But once that absolute value is isolated, if it's equal to a negative, that's when it's the null set or no solution. Because no matter what you plugged in here, 100 plus 1 is 100, absolute value of 100 is never going to be negative. No matter what you plug in there, you're never going to get negative out. All right, and then one final problem here. All right, so this one's a little trickier because notice we have x's on the left. We also have x's on the right. Okay, so that's what makes this problem a little bit harder. We already do have our absolute value isolated, so that's the one good thing. And if you kind of recall what we were doing once the absolute value was isolated, is we were making the right side positive and the right side negative in order to get rid of the absolute value. So we are going to do the same thing. We are going to make two equations here. One where I'm making the right side still positive. And when I do the other equation where I make my right side negative, you just have to be careful here because I'm going to make that entire right side negative. So I need to write it as negative the quantity of x plus 2. So as I go to solve this one on the left, I just want to get all my x's on one side and my constants on the other. So I'm going to subtract x from both sides and add 1 to both sides. That would give me 2x equals 3. And when we divide by 2, we would get x equals 3 halves. As I go to do that equation on the right side, the first thing I need to do is distribute my negative sign. So I'd have negative x minus 2 on the right. And so I would add x and add 1. So that would give me 4x on the left. Negative 2 plus 1 is negative 1. And then when we divide by 4, we get x equals negative 1/4. So our two answers would be negative 1/4 and 3 halves. So again, always that same. Left side positive, left side negative. If you have multiple terms on the right, like you have an x on the right, you're just taking the entire quantity, the negative of the entire quantity, and you would have to distribute that negative sign in. Right?